How's it going, guys? We've got another redox question, another acidic one, and this is to follow up the last video. It's going to be just a little bit trickier. I made up this problem. It's not a chemically sound equation. This wouldn't actually react this way, but it's a good example, and definitely I've had to do some problems that are similar to it on a test, and it was not fun. So here we go. Start off with step one. This is, again, I don't know if every instructor requires this or not, but 2 minus. We're going to write the individual charges per atom, per element. So for this one, it's easy, -1. This one is going to be, this is CrO7, if you can't read that. So each O is going to have a -2 charge, so this is going to be a -14 for all the oxygens, and that for this to equal 2 minus, we're going to actually have to have a +12 on this single element here. So then we go to the other side. Cr just gives us the answer there, 3 plus IO3 minus. So the full charge on this one is going to be -1. So we have a -6 on this oxygen, and this must be a +5 on the I. So there we go, we got those charges. That'll be helpful for determining this later, kind of double checking it. That's not usually the way I do it, but I find it useful as a measure to double check. Then I'm going to split them into two separate equations. So we're going to end up with the CrO7 2 minus yields the Cr3 plus. And then we're going to get the I. This one's nice and easy. I to IO3 minus. Okay, so now at this point, we can start checking out the formula, seeing, you can determine if you want which one you think is the which one is the reduction equation and which one's the oxidized one. Like I said, I usually like to put them in parentheses, and there we go. So if you think about it, the Cr here is part of a molecule that has a 2 minus charge, and then it gets a 3 plus, so it most likely loses a whole bunch. But however, this one here is a minus. Yeah, in this case, I'm gonna just wait. It doesn't really make sense because you're prone to making a mistake, and then if you get caught up in believing that you were right the first time, then you might change your answers later on, and this is not the most simple way of doing it. It's very easy to make a mistake at this step here. So anyway, we'll just move on to step 3. Balance the non-O's and non-H's. So first we have the CrO7 2 minus yields Cr3 plus. Easy peasy. Nothing, one here for the Cr. This time, same deal, I minus IO3. Easy, they're balanced. 4, balance the O with water. So we're going to have CrO7 2 minus yields Cr3 plus. Now there's 7 oxygens here, and there's only 1 oxygen per water molecule, so we're going to actually have to add 7 H2O over here to balance those oxygens. Now we have, on the next step down, I minus yields IO3 minus, so we have 3 over here. We're going to have to add 3 H2O over here to balance out those oxygens. Now we're going to have a fun time. Step 5, balance hydrogen with hydrogen ions. So here we go, we have, on this equation, on the top equation, we have 7 times 2 is 14 hydrogens. So we're going to have 14 hydrogen ions plus the CrO7 2 minus yields the Cr3 plus 7 H2O. So quick double check, 14 here, 14 here. We have 7 here for oxygens, and then 1 Cr. So we're good to go right now. We're where we should be for that equation. Now for this one, we have the 3 H2O plus the I minus yields IO3 minus. And we have 3 times 2 is 6 hydrogens, so we're going to add 6 H plus over here. Now we're going to move down step 6, balance the charges with electrons. Okay, so here we have 14 hydrogen plus the CrO7 2 minus yields Cr3 plus 7 H2O. Over here we have positive 14 on this side, and then we have the 2 minus, so this is going to end up being a positive 12 as the full charge of that side. Then for this side, as I said in the last video, H2O usually has a net charge of 0 because it's going to be a minus 2 here and a plus 1 here. Then we have the Cr3 plus here. So this whole side is a 3 plus, which means we're 9 apart. So in order to balance this, we're going to have to add 9 electrons to this side. Get this down to a 3. So this is, again, you can look back if you want to that sign I drew at the beginning. Let's see if I can fit them both in the frame. So if the electrons you're adding are in the product side, the reactant side, then it's probably reduced. So this is the equation with the CrO7 reduced. And I was originally looking at this based on the charges. It looked like it might have been the other way. So that's a nice way to double check it. Or like I said, just do it this way the first time. Okay, so now for the other equation, we have 3H2O plus I minus yields IO3 minus plus 6H plus. So the net charge of this side is going to just be a minus 1 because the O is neutral, like I said, in terms of its charge. This side we have the plus 6 and then the minus 1, so it's going to be plus 5. So now we're going to have to add 6 electrons to this side. And this is why this problem is going to be a little trickier than the previous one. As you can already tell, we're going to have to balance these. We have 9 here and 6 here. So those are all good. Their charges are good to go. 7. Set the electrons equal. So quickly we can just determine, okay, we have 9 on this side, we have 6 on this side. What's going to be the most convenient multiple to use? So we're going to take that 9 electrons plus 14 hydrogens plus CrO7 2 minus yields Cr3 plus 7 H2O. Take that whole equation there, and what's going to get it to 6? Well, you can multiply it by 2 and then get the 9 to the 18. So that, I always need to draw this arrow here because previously I just do line for line and you can get mixed up. So if it's just, I think you might be able to save you an accident there if you just write the arrow. So we have now 9 and 9 is 18 electrons plus 28 hydrogens plus 2 CrO7 2 minus yields 2 Cr3 plus 7 to 7 is 14 water. Just do a quick check there. 28 hydrogens here, and then 14 times 2 is 28. We have 2 times 7 is 14. We have 14, and we have 2 CRs, 2 CRs. Okay, so everything looks good now. Everything's still balanced with this equation. Now we're going to take the other equation, which was the 3H2O plus I minus yields IO3 minus plus 6 hydrogen plus 6 electrons. And 6 times 3 is 18. So we're going to multiply this by 3. So 3 by 3, now we have 9 waters. 3I minus 3IO3 minus plus, what do we have? 3 by 6, 18 hydrogen ions, and then 18 electrons. So now we're in a good spot to move down to step 8. We can balance and put these, so we're going to compile these together, combine and reduce. So now we have these two equations. We're going to move them down. This is, again, like a very easy step to make mistakes on. Hopefully your professor gives partial credit if you make a mistake on this, just moving the data down. It can be really complex to stay organized, especially if your writing is not very neat. So I do this the same way I do the other ones. I kind of just go right to left. Plus 28 hydrogens, plus 2 CrO7, 2 minus 7. So we've got all this. Now we're going to add plus 9H2O plus 3I minus yields. Now everything from this equation, 2Cr3 plus 14H2O plus 3 IO3 minus plus 18 hydrogen ions plus 18 electrons. Great. Okay, so now first things first, bam, bam, get rid of those electrons. That's the most convenient, and that's exactly why you did all these multiplying steps here. So now we have 28 hydrogen over here, 18 hydrogen. Whichever side there's less of, cancel it out. So minus 18 hydrogen, and then minus 18 hydrogen over here too. I like to just kind of move it down as I go. So the 8 minus 0, we're going to end up here with a 10 hydrogen ions, H plus we have the 2 CrO. Almost always you're not going to be able to do too much about the compounds that are in a different setup than on the other side. But for water, here we go. 9 H2O over here, 14 H2O over here. So we're going to minus the 9 H2O from both sides, just like on a regular equation. Minus 9 H2O. So now we're going to end up with 5 H2O over here. Okay, so we got rid of that. Now the 3I minus yields 2Cr3 plus 5H2O plus 3IO3 minus. Now let's just do our check. Check the charge of everything. We can do that one first. Let's see, we have a plus 10, minus 2, minus 1. So this should be a plus 7. Then we have 3. All right, something funky here. So let's see. Oh, it's a 2 by 2 minus. So we have net negative 4 here, negative 5. It's a plus 5 over here. And then we have the 3. Yeah, something's still not adding up. Let's see here. I wonder if this step isn't working because, like I said, the actual equation here is not a proper chemical equation. But it's possible I just missed something. Let's see here. So we have the 10 hydrogen, 2 CrO7, 3I minus, 2, 3 plus, 5 of these. Oh, and this is 3 minus, I'm sorry. So the 3 minus, wait, so that's 6 plus 6, 3 minus, yeah. No, it's not going to work in this particular problem because of the way I set it up. But the other thing we can charge is check the number of elements. So we have 10 hydrogen here, and then we have 5 times 2 is 10. We have 2 by 7 oxygen, so 14. We have 5 plus 3 by 3 is 9. There we go. We have the Cr, 1 here, 2 here, 2 here. And then I, 3 here, and 3 here. All right, cool. So we're good to go on that. So this is the final equation here. Again, sorry about those charges not adding up. That's just the way that your professor is going to schedule. They're going to set up an equation that is going to make sense in the end, charge-wise. Then we can check again here which one's reduced and which one's oxidized, or which one's the oxidizing, which one's the reducing equation. Here we have the electrons on the product side. So the 3H2O plus the I minus. The I minus had it there. Let's see here. so oxidized. So that should have been the answer there. Okay, cool. And just this is the mnemonic again for the diatomics. Have no fear of ice cold beer. And that's hydrogen, nitrogen, fluorine, I think is the ion. Oxygen, iodine is it? And then carbon.